In the last lecture, we looked into if-else statement that had the following flowchart. So the control comes to a decision point, which is represented by a diamond, where we evaluate an expression that compares two values and produces either true or false. So depending on the result of this expression, we either take the y part, the yes part, to true part, or the else part. So assuming that the expression is true, we go into the control follows the y path, the true path, and we execute statement one, which we said that is the if part of the statement. If the expression evaluates to false, then we follow this path of the flowchart and execute statement two, which is the else part of the statement. And we either execute if part or the else part, and then the control continues with the next statement after the if else statement. The expression evaluated in the decision box in here is called a relational or Boolean expression. And obviously, you need operators, relational operators, to form these expressions. And here are the 6 operators, relational operators available in almost every programming language out there. So let's look at equality. So equality is equal, equal. Remember, in C++, a single equality symbol represents an assignment. So we use that operator to fill a value into a variable. But in order to test for equality, you put two equal signs. This is a common mistake. Instead of putting two equal signs to represent equality, sometimes you forget one of these and use the assignment operator. So this is a common mistake that you have to pay attention to. Not equal is you simply change the first equality with not symbol, which is the exclamation point. So exclamation point equal to means not equal, and the other 4 symbols are they are what you expect them to be. So less than is this, less than or equal to, greater than, and greater than or equal to. These operators are available in almost every programming language that you'll learn from now on. Let's look at an example. Assume that you've got 3 integers, a equal to 1, b is equal to 2, and c is equal to 3. And here are some expressions, and here are their truth values. So let's look at the first one. Is a less than b? Remember, a is 1, b is 2, so is 1 less than 2? The answer is yes, so 1 is less than 2. What about the next one? So we are trying to evaluate whether a plus b is greater than or equal to c. So let's do the addition first. So a is 1, b is 2, 1 plus 2 is 3. Is 3 greater than or equal to c, which is 3? So 3 greater than or equal to 3? Yes, this is true. The third one, b plus c. So b is 2, c is 3. So b plus 2, c would be 5. Is 5 greater than a plus 5? A is 1, so it's 1 plus 5, 6. So is 5 greater than 6? That's obviously false. What about the fourth one? C is not equal to 3. We know that the value of c is 3, so 3 is not equal to 3 is false. 3 is in fact equal to 3. The last one, b is equal to 2. Remember, the value of b is 2. Is 2 equal to 2? Yes, this evaluates to true. Although C++ has an explicit bool type to store the Boolean values, integer values are also considered to be Boolean values in C++. And this is an artifact of C++ being an extended version of C. So in C, there is no Boolean data type. Any integer, so integers are used for Boolean values. And the general rule of thumb is 0 is considered to be false. Any non-zero value is considered to be true. Although C++ added the Boolean data type, the bool data type, because it's an extension of C, it had to be backward compatible to C. That's why this rule, the 0 is false and any non-zero value is true, has to be enforced in C++. So let's look at an example. This is example 7. So let me go to the sample code. It's right here. What we are here saying, I'm going to go step by step again in the debug mode. So think about it. This exclamation point is the negation operator, which negates the value of the Boolean expression. So remember, 0 means false in C++. So when you say not 0, it becomes true. So not 0 is true. So we should see 0 is false on the screen. And as you can see, 0 is false. If 5, then 5 is true. Again, 5 is a non-zero value, so 5 is true. So that means we are going to see 5 is true on the screen. So let's have now two integer variables, x and y. X is 3, y is 3. And we're just doing x plus y. Again, this might look very strange because this is an arithmetic expression, and we are using it as a Boolean expression. But it is because, like I said, because C++ is a backward compatible to C, any arithmetic expression is also a Boolean expression. So x plus y is 3 plus 3 would be 6. 6 is a non-zero value. That means it is considered to be true. So we should see x plus y is equal to 6, which is true on the screen. What about x minus y? X is 3, y is 3. So if you do x minus y, it would be 0. This time, the result is 0. So 0 is false. So we should go to the else part and say 0 is false. So remember, the rule of thumb is when you evaluate any arithmetic expression, if it evaluates to 0, it is considered to be false. If it evaluates to any non-zero value, then it is considered to be true. For example, if the result of the expression is minus 5, it is still considered to be true. So any non-zero value is considered to be true. This is something that you have to be aware of when you're programming in C and C++. I already mentioned that a single equality symbol is the assignment operator in C++, and two equal signs is the equality operator for C in C++. A common mistake is to confuse these two operators, and instead of writing equals equals, just to write the assignment, use the assignment operator to mean the equality operator, and that leads to some very difficult to detect errors. So let's look at an example. If you've got an integer a equal to 3, see this is an assignment operator because there is only one equal sign. So you're basically assigning 3 to a. But let's look at the next if-else statement. So if a is equal to 5, do some, print something, and else something. So looking at this code, you can think that the intention of the programmer is to check if a is equal to 5. And if a is equal to 5, then it prints the statement. Otherwise, it prints the next statement. But let's see what actually gets printed on the screen. So, right? So when you execute this code, you'll see that a is equal to 5 gets printed. And you would think what's going on because the value of a is 3. A is not equal to 5. So why are we seeing a is equal to 5 on the screen? This doesn't make any sense. And the reason is that the programmer has confused the assignment operator with the equality operator. Look at the if statement, the expression in the if statement. It is not using the equality operator equals equals. By mistake, the programmer has used the assignment operator. So it's a equal to, a is assigned to 5 rather than a is equal to 5. So what happens is when the compiler evaluates this expression, it's going to say, okay, this is an assignment operator, and it's going to change the value of a to 5, right? So a is equal to 5, meaning it's going to fill up the value of a to 5, and it also evaluates to 5, which is a true statement in C++. Remember, any non-zero value is considered to be true. So the compiler says, okay, this is true, so I'm going to execute the if part of the statement. So that's why you're seeing a is equal to 5. Although the value of a at the beginning is 3, it is changed to 5 in here, and then 5 is equal to 5, obviously, because, the statement evaluates to true. So this is something that you really have to be aware of when you're writing these if statements. Make sure that you always use equals equals to mean equality, and when you use a single equal sign to mean assignment. And do not make this mistake. I see this all the time, students coming in during the office hours, complaining that their programs are not working. And when we look into the details, we see this error all the time. I also make this error. I mean, it's a typical programming error. You have to. Another common mistake is to compare the Boolean variables with true or false. So you should never write expressions like this. So valid is a Boolean variable initialized to true. You should never write if statements as shown in here. You should never say valid is equal to true. Rather than writing code like this, you should say if valid. Remember, valid is already a Boolean variable. So its content is either true or false. So there is no reason to compare valid into true or false. You can just say if valid, and this is the way you should write it. And there's a reason for this. The reason has to do with confusing equality with assignment operator. Let's look at an example. We have a Boolean variable valid initialized to false, and we've got an if statement where the programmer checks if valid is equal to true, then print valid is equal to true, else valid is equal to false. When we execute this statement, we see that valid is true gets printed on the screen, and you may ask yourself, but the initial value of valid was false. Why did we see valid is true on the screen? And it's again got to do with the programmer confusing the assignment operator with the equality check operator. So instead of saying valid is equal to true, the programmer typed valid is assigned true. So valid is assigned to true sets the value of the valid to be true, which evaluates to true. That's why we are executing the if part of the statement, saying that valid is equal to true. Again, this is a very common mistake and is usually very difficult to find. So bottom line is, when you have Boolean variables, do not compare them to true or false. Simply say if valid, if whatever. So never compare Boolean variables to true or false. That's something that you have to always keep in mind. Another caveat is, do not use the equality equals and not equal to operators when comparing to floating point numbers. Recall that floating point numbers can only be approximated in programming languages, which means that what we think is equals in a math equation may not be true when represented in the computer. For example, consider the following code. We've got a double x is equal to 0.1 plus 0.2, and another variable double y, which is equal to 0.3. And then we have an if expression saying if x is equal to y, and say 0.1 plus 0.2 is equal to 3. Otherwise, they're not equal to each other. If you think about it from a mathematical perspective, this is x should be 0.3, y is 0.3. So when you compare x and y, they should be equal to each other, right? But when you execute it in a machine, you'll see that you'll get 0.1 plus 0.2 is not equal to 0.3. Again, this would confuse you, saying that what is going on. Let me show you this example. Let me actually run it so that you actually see that this is actually what gets printed on the screen. So here it is. Let me again go step by step in the debug mode. So here we are. So that's x and that's y. Look at the representation of y. It is 0.299999. It is impossible to perfectly represent 0.3 in a machine. And when you compare is x equal to y, the answer is no. It's not. They are not equal to each other. Because, I mean, look at their representation. Their representations are not equal to each other. Let's think about equality of two floating point numbers from the perspective of math. The green points in here represent integers. So 1 is an integer, the 2 is an integer. And we know that integers are exactly represented with no errors. Therefore, we can use the equality and not equality operators to compare two integers because their representation is exact in a computer. But let's now look at two floating point numbers, the blue point and the red point. The blue point representing 1.7386, the red point representing 1.7387. So the question is, are they equal to each other? You may argue that they are not because, they are not the same number. But how about if I make the blue point 1.7386 0.95. So I'm making it a little bit closer to red. So bottom line is, at which point are you going to say they are equal to each other? So how many precision numbers do you want after this to assume that they are actually equal to each other? Remember, from a mathematical point of view, the precision after dot could have infinite number of digits in there. So at some point you should be able to say, okay, they are now equal to each other. They are so close to each other that I would assume they are equal to each other. The bottom line is, there is no way for the machine to make that decision for you. As a programmer, you have to make that decision. So you have to define what it means for two floating point numbers to be equal to each other or not equal to each other. And the way to do that is to define a epsilon epsilon distance. So basically define the distance beyond which you would say they are equal to each other. If the distance between the 2 points is more than the epsilon value, the distance, then you would say that they are not equal to each other. So the way to actually compare these two numbers is to define the epsilon. I'm going to define the epsilon to be 0.0001. You could make it smaller or bigger. It's all up to you. That's why I'm saying, as a programmer, you have to define what it means for two floating point numbers to be equal. So what I did in here was double epsilon is equal to this. So I'm assuming that if the distance between these two floating point numbers is less than this number, then they are equal to each other. Otherwise, they are not equal to each other. And then you're basically saying the way to compare this is take the absolute f absolute. Now this is a function from the math library. So f absolute floating point absolute value difference x and y. So you take this distance between x and y, take the absolute value of this. If it is less than epsilon, then you're saying they are equal to each other. Otherwise, they are not. So let me show you this code. It's right here in the same example. So let me stop it, the debugging. So I'm defining an epsilon value, and I'm saying I'm going to take the distance between x and y. If the distance between these two floating point numbers is less than this epsilon, I'm going to assume they are equal to each other. Otherwise, I'm going to assume they are not. So bottom line, it is the programmer's responsibility to define when two floating point numbers are equal to each other and when they are not. And let's run this thing, and now you're going to see that these numbers are equal to each other, because that's how we defined their, basically we define what it means for these two floating point numbers to be equal. So if you make it, probably more with more precision, so I'm going to assume that they are equal only if the distance is less than this. Maybe it's still going to say false. So let me run this. I really don't know what's going to come out of this. It's still coming to be true. So bottom line, when you do not compare two floating point numbers with using the equality and not equal to operators. That's wrong. You should always compare them using this method. Assume that we want to write a program where we not only want to know if x is less than y or x is greater than y, but we also want to know whether x is equal to y. We can implement this code as follows. So the first thing is we compare if x is less than y. If that's the case, we print yes, x is less than y. Otherwise, if we come to the else part, x is either greater than y, or x is equal to y. I don't know which one it is. So I have to write another if statement. So what I do is, if x is equal to y, right, in the else part, then I'm printing they are equal to each other. Otherwise, x must be greater than y. So this is example 9. Let me go in there. So let me go step by step. So let's say x is equal to 2, y is equal to 3. Again, go in the debug mode, and let's see how the program executes step by step. So if x is less than y, x is 2, y is 3, obviously 2 is less than 3, so we are executing the if part and skipping the else part altogether, coming to the return statement. Let me change the values now, so let me make it 3, 3. So again, start the debugging mode. We are at the decision point. If x is less than y, 3 is less than 3 is false. So we jump to the else part. Here we have another if else statement, as you can see, because I don't know if x is equal to y or x is greater than y. So I have to write another if statement. Now I'm comparing if x is equal to y. So is 3 equal to 3? Yes. So I'm going to execute this statement and then jump to the next statement after if. Let me make x greater than y this time. And let me go step by step again. So it's x is 4, y is 3. Is 4 less than 3? No. So we again jump to the else part. The first comparison we make is if x is equal to y. So x is 4, y is 3. So they are not equal to each other. Then we go to the else part and we print 4 is greater than 3. As you can see, we have we have three conditions in here. So x is either less than y, x is equal to y, or x is greater than y. But this is how we have to write it. So instead of nesting the second if statement inside the else statement, which is what we did in the previous example, we often write it as follows. This is called the cascaded if statement. This is example 10. So what we do in here is we say if x is less than y, then we say else if x is equal to y, and then else. So it's in a sense if, else if, else if, else if, and then else. This is called a cascaded if statement and has the following syntax. So we come, again, this is a cascaded if statement syntax. We come to the decision point. We evaluate the first expression, expression 1. If it is true, we execute statement 1. Otherwise, we go into else if and evaluate expression 2. If that's true, then we evaluate expression 2. Then we do a else if next, and finally we have an else. Again, the part in square bracket indicates that everything in the else if and else part is optional. So you don't have to have these in an if statement, but you have to have the if expression and statement 1 at least. But these are all optional. So let's go to example 10 now, just to show you the same code written more clearly, I would say. So let me start again. X is equal to 2, y is equal to 3. So this is going to be true, and we'll execute this statement. Again, let's go maybe step by step just to show you how the execution proceeds. All right, so here we are. X is less than y. Is 2 less than 3? Yes. So we execute this and then jump to the next statement after if. What if they are equal to each other? Then again, we'll come to the first if statement, first expression. That's false. We jump to else if x is equal to y. Yes, we are going to execute this statement and then jump to the next statement after if. And if x is greater than y, then we'll start at the top, evaluate all expressions until all of them are false. That's why we go to the else part and execute it. So this is again called a cascaded if statement, and you would see some programming languages having a short expression. Instead of saying else if, there is an elif statement, for example, in Python. This elif does not exist in C++, but like I said, this is such a common construct that some programming languages have special keywords for it, like Python. Python has elif for it, but in C, Java, you have to write else if, as shown in here. Let's finish our discussion on the cascaded if statement using a more complex expression. Let's say we know the final score of the student, which is, let's say, 77, and we would like to assign a letter grade to the student. So here's how we can do it. If final grade is greater than or equal to 90, that's an A student. Else if the final grade is greater than or equal to 85, that's an A minus. Then if it is greater than 80, then it's a B plus. Greater than or equal to 75, that's B. Greater than or equal to 70, that's a B minus. And if it is greater than or equal to 55, that's C. Otherwise, the student fails. This is just a hypothetical letter grades assignment. So what will happen is the control is going to start at the top, evaluate these expressions one at a time until one of them is true. If all of them are false, we're going to execute the else part. So let's look at this code. This is example 11. The grade is 77 in this example. Again, let's go step by step just to see which of these expressions we evaluate. So we come in here, we say Is 77 greater than or equal to 90? No, we go to the next else if. Is 77 greater than or equal to 85? It's not, so we go to the next one. Is it greater than 80? No. Is it greater than or equal to 75? Yes, so the student gets a B grade. So the bottom line is the evaluation always starts at the top and goes towards the else statement one at a time. So as soon as one of these expressions become true, we execute the statement that's inside that if part or else if part, and then the control directly jumps into the next statement after this cascaded if statement. You have to be very careful when writing these cascaded if statements. Look at the comparisons. We have a final score. We are first comparing with the maximum value, then the next maximum value, then the next maximum value, then the next maximum value. You cannot mix these comparisons. For example, I cannot say if it is greater than 85, the student gets an A minus. Then if it is greater than 90, the student gets an A. This is not going to work. So let me show you. Let's say assume that the final score of the student is 92. So according to our logic, the final score is greater than 90, so the student should get an A. But let's see what it gets. Let's just debug this. We come to the first if statement. Is the final score greater than or equal to 85? Yes, so the student gets an A minus. So the bottom line is, as soon as one of these is true, we will never go back and check the other else if statements. So you have to make sure that the ordering of these else if statements is correct. Think about it. If the score is, let's say the final score is 92, it is greater than 90, but it is also greater than 85. So when you evaluate this expression, something that's greater than 90 is definitely greater than 85. So you would always execute this statement, and there is no way you can execute this statement, right? Because think about it. You want to check if the score is greater than 90 after checking if it is greater than 95. So as soon as the score is greater than 85, you will always come here. Greater than or equal to 85, you will always execute this statement. So there is no way you can execute this else if part. So this is wrong. So you have to place them correctly. So that's why, because this is a greater than or equal to operator, you have to start with the maximum value, then continue with the next maximum value, and so on. But if this was, let's say, and let's delete this. If this was the smaller than or equal to operator, then you have to start with the minimum value in that case. So let's assume we've got a number 15, and we have the following cascaded. If number is less than 10, then say cout less than 10. And so on. So I'm just going to copy and paste. So if it is less than, so if it is else if, and else if, and else. So if it is less than 10, it's less. So if it is less than, I don't know, 30, 50, sorry, this 30, 50, otherwise cout greater than or equal to 50, right? So that's what it means. So in this case, because the number is the operator is less than, we have to start with the minimum value, then the next minimum value, then the next minimum value. Otherwise, if you put the maximum value in here, any number that's less than the maximum value will automatically be smaller than the other values. We would never be able to execute these statements if you write it in the wrong manner. So this is the way you're supposed to write it. So let's just execute this code so that you see that it's not less than 10, it's less than 30. Well, let's make it 35. Now it's less than 50, right? So we execute this. And if it is, I don't know, 60, then it is definitely greater than or equal to 50. So we start here. This is false, this is false, this is false. That's why we are executing the last statement. The bottom line is, when you're writing these cascaded if statements, pay attention to the order in which you put these comparisons one after the other. And you have to put them in the correct order. Otherwise, if you put them in the wrong order, some of these else if statements may never get executed.